So moving on next, we have a talk by Dr. Noah Petro. He is a project scientist for LRO at Goddard Space Flight Center, and he's going to talk about the gift that keeps on giving, LRO at 11.
All right, thank you so much. Com check, we're good?
Yes.
Okay, fantastic. Uh, Thank you again for this opportunity to talk about spacecraft that has really revolutionized our understanding of the moon and its place in the solar system for now 11 years. It's been a remarkable run. I can remember back to the very early LSI, NLSI forums and the excitement around the initial release of data, and here we are 11 years later. And as Ryan so eloquently showed, the data keeps on coming and we're learning more and more about our awesome neighbor in the sky. So let's just talk a little bit about LRO right now. There's been a number of papers that have come out in the last several weeks, generated some interest. Many are after the paper just come out as some Heggie looking at dielectric properties of the surface, particularly at the floor of larger craters in the Northern Hemisphere. And Ariel Deutsch's paper on the roughness of polar craters is an indication of the age of volatiles. One of the really remarkable things about these papers is how broad the types of science that we can do with LRO data, particularly pointing out the Ariel paper, it's a derived product from the topography that Lola has been collecting. Again, 11 years later, I think it's remarkable that we're still harvesting such a wealth of information from our vast data sets. And as Ryan pointed out in her talk just a moment ago, that we are pushing the boundaries of what we can do with our data. Again, looking back what we thought we would do with a 1 or 2 year mission, to be able to have these kinds of parameter maps over multiple sites because of NAC images is truly remarkable. LRO is healthy. For an 11-year spacecraft, we're pretty soon going to be able to qualify for vintage license plates. You may remember from several years ago, we had turned off our miniature inertial measurement unit. This helps us preserve the life of that object on our spacecraft to use in case of emergencies. Because we turned that off, we needed to come up with a completely new mode to do slews. There was a period of time that we were not doing slews. We're now back in a slew mode, and we continue to refine how we operate the spacecraft. Ben talked about the SO office at headquarters. LRO is now completely managed within that office at headquarters. Gives us an opportunity to work directly with CLPS landers through the Johnson Space Center and provide landing site support for those commercial landers. As everyone has experienced an impact because of the pandemic, LRO is no exception. Goddard is at stage 4 still, which means we have a very limited amount of people who can go on center. We have adopted a very rigorous social distancing scheme for the operations team at Goddard. No more than 3 people in our operations room at any one time. We've been rotating people in and out of the room to minimize direct contact. They're in close proximity for no longer than necessary and then sent home when we have our commands uplinked for the day. So far, the team is healthy, morale is high, and we've been able to manage LRO in this pandemic, I think, remarkably well. We've also at the same time been training new members of our operations staff, which is giving us a certain amount of a deep bench for continued operations. I'd like to also point out that we operate using for uplinks periodically the global data network, and so we were expecting hiccups, particularly with the Madrid DSN station. That didn't happen as Spain went into a very dire situation with the pandemic several months ago. We also, during the pandemic, or at least recently, had penumbral eclipses where we monitor the battery since we lose direct solar power for a short period of time. LRO went through that with flying colors. Let's talk a bit about the future. We are right now in our 4th extended science mission. This will take us through September 2022. We now have these 3-year extended missions, which gives us a little bit of breathing time from proposing to implementing our mission to preparing for the next senior review cycle. We anticipate proposing to ESM our next extended science mission which will be due in March of 2022 or thereabouts, and we will ramp up the preparation for that starting next calendar year. We have approximately 16.7 kilograms of fuel remaining on the spacecraft, of usable fuel on spacecraft, which means given the mode at which we operate and our low fuel consumption, we plan that we can operate through April of 2027 at this point. So we have several more extended science missions to go. So those of you on the LRO team, keep those pencils sharp. Now, we really have minimized the amount of fuel we use on an annual basis. We do regular momentum unloads, which takes us about over 1.5 kilograms per year. We will do phasing burns prior to eclipses if we need to change our orbit slightly. And we will, if the need arises, change our orbit to optimize observations during, for instance, landings. We were looking forward to the eclipse landings coming up and potentially trying to make some scientific observations of those landings or around the time of the landings. One important note is that we are continuing to drift away from the poles, meaning that we get this incredible density of coverage around the poles. So at the plot at the bottom here, you can see that our orbit is right now at an inclination of about 86 degrees, plus or minus about 0.5 degree. By 2027, we will be about as far away from the pole as we get, to about 83 or thereabouts degrees. This means that we are going to create an incredibly dense coverage of data over both poles, both north and south. This is really exciting for us, particularly with the interest in polar science coming up in the next several years. I know that some are having a hard time hearing me, so hopefully that's been, you're able to hear me now. Let's see, just as a reminder, we are in this low fuel consumption orbit, and ever since 2011, we've been in a highly elliptical orbit, which allows us to stay in orbit with a minimum amount of fuel use. Without that orbit, we would have met the same fate Bethany was talking about with Lunar Trailblazer. We would have litho-braked by now. At this point, our orbit is stable enough that we don't anticipate anytime in the next 40 years hitting the moon. Let's see. So since 2011, we've used just under 30 kilograms of fuel. As my daughter comes in to show me that she lost her first tooth. Very exciting. Congratulations, Amelia. The Tooth Fairy will make a special visit to you tonight. We're 1 decade into operations. We are a unique mission in that regard, that very few missions have operated as long as LRO. In fact, no missions have operated as long as we have. I try to show that there's these missions that have operated for 1 to 2 years. They capture a snapshot of the moon. We are now in this sort of extended duration, capturing the dynamics of the moon, looking at how the moon changes over time due to impact, due to interaction with the solar wind, and indeed due to the landings or interactions with other spacecraft, whether planned landings or crashes, as we had with the Vikram lander. And so this extended period of operation at the moon really gives us a completely new view of the moon and a completely new picture of how the moon is evolving underneath our feet. So I anticipate that line will continue to grow to the right, and the science that we can get out of that extension really increases. Statistically speaking, I think we're due for a larger impact than we've seen so far. We're all really excited for the chance of capturing what happens when you get a 1 kilometer crater that forms on the moon, and so hopefully we'll be right there. As we get to this point, we're learning that the science that we do enables the exploration in the future. LRO data. Hopefully everyone has a calendar reminder set every 3 months for when we deliver a new batch of data to the PDS. Of course, LROC is now delivering every month to the PDS. This is an incredibly valuable resource. Every single month, we're getting new data for the community, for the world to use. We had delivery number 42 last month, and all of the data not only gets put on the PDS, but is also eventually ingested into the Quick Map tool. I'm going to give a little tutorial, quick highlight of that in a moment here. I'd like to also highlight that the Goddard Scientific Visualization Studio is a great resource for highlighting visualizations of our data products. Okay, so I'm going to hopefully run a video. It may be a little staticky of the Quick Map tool of some of the enhancements that came out within the last several months. But one of the really great tools that we can do is now interact with the data in clever ways. I'm going to pull up the sun visibility map. Elliot showed off some of this material. Not only can you display the data, but you can actually kind of interact with it, map it in different ways, different approaches. And so what this means is that everyone can go off and find their favorite particular landing site. There are actually ways that you can do Boolean expressions. Show me areas that have slopes less than 10 degrees with visibility of the Earth of X or Y amount of solar visibility. Different compositional parameters as well. So this is a really incredible tool for digging into the resources that we've produced as a mission and making it available again for the entire world. I know that I'm now at about 10 minutes. I will make some of the links available. I'm going to end here with a visualization that we have of the lunar South Pole over the year 2024. This is a video that we'll be releasing in the next couple weeks, not only to remind ourselves of what will be coming down the line, hopefully in 2024 with Artemis 3, with the next man and first woman to walk on the moon, but also the chance for the science that LRO can do to support that. You know, we're incredibly optimistic about the future. I think if we've learned anything over the last several months, it's that to engage with the public about science, we really need to be effective communicators of what we're doing, what our goals are, and how long it's going to take. And I'm excited for this opportunity, and I'm looking forward to enjoying that ride with all of you. With that, I'll conclude and open the door for questions.
All right, so do we have any questions? We have like 1 more minute left, so audience can raise their hands or put up their questions in the chat box and I can read it out if there are any, or we can move on to the discussion session. All right, so we'll move on to the discussion session, I guess. I have like quite a bit of questions from more or less a lot of speakers in our session. First question would be for Noah, since you gave the last talk and it will be more relevant. So LRO was a great mission and is a great mission to be true, but what next? What do we plan on having after LRO? Because LRO has kind of, made us very much, I would say, addicted to getting high resolution data. And what next are we looking up to after LRO?
Well, you know, right now we have a full spectrum of opportunities coming up. We've obviously, between Trailblazer, CLIPS, what we might get in New Frontiers as well. I'm eager to see the possibility of a South Pole Aiken sample return, or especially a geophysical network that will push the boundaries of that decade of operations. But you know, we've definitely opened the door for further questions about the volatile cycle at the moon, and of course, Trailblazer will address that. I think other orbital observations of the detailed trace of volatiles as it moves across the surface or don't move across the surface. That's a great hypothesis to test. You know, the possibilities from both orbit and surface are limitless. I would also like to add, though, the importance of having this synergy between a landed mission and observations in orbit. And you know, we've been able to interact with a couple rovers that are on the surface, at least observe their movement, but you know, the possibilities of making really compatible orbital and surface observations are really exciting. So for instance, if we have a geophysical network that goes to the moon as part of the New Frontiers, a compatible orbital dynamics mission that is measuring, you know, the magnetic properties of the moon at high resolution, coupled with high resolution imaging. I don't think there'll ever be a day where we don't need more high resolution imaging of the lunar surface, because, you know, for one, being able to observe a landing site for geologic context, or to see where an astronaut actually goes. We've been able to do this post facto Apollo observation, but boy, wouldn't it be great to have not only coincident high resolution imaging during a mission, but also before and after. And I'll wrap up there. I could answer that question much longer, but I don't want to suck up all the oxygen in the virtual room.
Maybe I'll have one last question. So LRO, like looking up to the poles, we are like very much in need of, you know, high resolution DEMs, which can be created using NAC stereo pairs. But again, like we have really limited coverage, I would say, in like darker regions of like stereo pairs. So I understand that LRO is already in like quasi stable orbit, but are there any plans to like, you know, increase the coverage and get better stereo pairs, or like to create more NAC DEMs for that, like for helping future landing missions and everything else?
Sure, NAC continues, the LROC team continues to request stereo observations of high priority targets. We have many that we've already collected. I would also like to point out that we have much more work we can do with the LOLA DEMs. The LOLA team has worked hard to improve the quality of the polar DEMs. Granted, they're going to be at about 5-meter resolution, but for those that have worked with the LOLA polar data, it does also have some artifacts in it. The LOLA team is going back over that and working really hard to remove those artifacts. So I'd say that the story of our polar topographic data is far from complete, and there will be more work done. It's very challenging to get those NAC DTMs of polar sites. The lighting conditions at the pole are very, very harsh. And we already have some DEMs that are in the USGS archive for polar locations, and the LROC team continues to work to collect more data. But those high resolution DEMs are very intense products to generate, and so it takes time to make them. But as long as we collect the data and get it in hand, we'll have it for use for future generations.
Thank you so much. I have one more question from Dr. Bethany. So Trailblazer is like a mission I'm personally looking very much forward to. How would you suggest other people who are not currently involved with the mission, how will they have an opportunity to be involved in future, or do you have any openings, any grants or anything coming up? Is she here? All right. I think she's not here.
If we lost Bethany, I can jump in if that's okay.
Yes.
As deputy. So because it's a simplex mission, we have a very, very aggressive budget of like 55 million. But one of the things we're hoping is that we can, or that NASA will consider a participating scientist program or something like that to help bring the community in. Another thing that we will likely do, especially depending on how all our comms trades end up, is opening up the opportunity for community members to select or to propose targets that we might look at. So we're going to do as much as we can. And if you visit the website, you'll see we are already trying to kind of bring in as much of the public and the community as possible to help them be involved as we can with the mission.
Thank you so much. Do we have any more questions from the audience? I can maybe take a second to look through if there are any. All right, so I think we have come towards the end of this session, and I would like to
actually, can I ask a question of Rachel for Trailblazer?
Yes, please go on.
All right, so Rachel, just what's your PDS archive plan? Everything's going to go into PDS after mission, after 3 months, posted on GitHub, X archive. I don't, how is it going to work?
Yes. I can't remember right now what we said for our first delivery. But we just had a telecon about the different products and how we're going to deliver them. We're talking about doing a kind of M-cubed style for HVM cubed, where we've got the backplanes and all of that. We will presumably get the radiance data and those kind of data out as quickly as possible, because it's a small team with not a lot of funding. The more derived products will probably be a later type delivery like we had before. But yes, I mean, it'll go in PDS like typical. And if you want, I will look up the promised timelines for deliveries.
All right.
Nice beard, Noah.
So we have kind of come towards the end of the session, and I would like to thank SRV for giving us the opportunity, me and Kelsey, both of us, the opportunity to chair this wonderful session with wonderful speakers. And I think we can probably move back to the next session, I guess.